So today we're going to 2.6 transformation of functions. 2.6 transformation of functions. So today we're going over 2.6 transformation of functions. So first of all, before we learn how to graph a function by using the plotting points, like by choosing a random variable as x coordinate, and then we plug it inside the function, we get the y coordinate. This point, we get the order point, and then we put it in the Cartesian plane. Then we use this point, we draw a line, or we draw a curve, between this line, then we get the graph of the function. But we're going today to graph a function in different way. This way, we have to know the basic or the original functions. Then by using the original function, we can draw another functions. So let me first of all give you the graphs of the basic functions. We're going to use it today. So the first function we're going to use it is the linear function. Linear function is a function is the function of the form. If I ask you for graphing the function f of x equal, for example, x plus b. So the graph for this function, as we learned before, is going to be a line. So this line depends how is the shape. If here the m is the slope, this is here. M here is the slope. If the slope is positive, the graph has a shape like this. If the slope is negative, the graph is the line has a shape like this. Okay, so suppose m here, suppose m is positive, so the graph will be look like this. A line has a graph this shape. Okay, this is my x-axis and this is the y-axis. Okay, another different cases of this line, suppose, and also b here b, as we learned before, this is the y-intercept. This is the y-intercept here, b, y-intercept. This is mean the graph intercept the y-axis at this point. So this is my b. Okay, and here is the slope of this line is m, and this is positive. Suppose I have another function f of x equal b, since the slope is 0, since here m is equal 0. So this is like a special case of the linear function. M is 0, they give me f of x equal b. So we're going to, so we know this, the graph of this function, as we see before, it's a horizontal line. As a horizontal line look like this. And so the horizontal line, but the y-intercept again is b. So suppose b is positive here again. So the graph will be look like something like that. So this is again my b. And this is the function f of x equal b. and here f of x equal mx plus b. Okay. Any graph for the linear function so far? Is it clear how to graph the linear function for the first one and the second one? Okay, now we have to know how to graph the power function. So the power function I'm going to graph the even powers. For example, f of x equal x squared. So as we learned about this function before, it's a parabola. It's a parabola. It's look like something like that. And it's open upward because the coefficient of x squared is positive. So the graph is gonna be something like this. Okay. This is f of x equal x squared. What about if f of x, if I give you another function, f of x equal x to the 4. So the graph of f of x equal x to the 4 is similar similar to the function f of x equal x squared. But the different things here, I'm gonna show you in the graph. Different things would be like here, close from the interval 0 to 1, be like more closer to the x-axis, then goes up. Okay, be closer to the x-axis and goes up. At 1 is 1, this point is 1. At -1 also is 1. But from 0 to 1 will be like more closer to the x-axis. Okay, this is the difference between f of x equal x squared and f of x equal x to the 4. Okay. Now, on any function f of x has like even power x squared, x to the 4, x to the 6, x to the 8, any even power, the graph will be look like a parabola. But the difference is between 0 and 1 will be like more closer to the x-axis, then goes up like the same things. Okay. How is open? It depends on the sign in the front of the leading term. If it's positive, the graph will be open upward. If it's negative, will be open downward. Okay. So the same things for f of x equal x to the power 6, x to the power 8, wherever. So let me write here down for the even power. So we're going to use only x squared and x to the 4. This is what's the basic function we're going to use it during this section. Okay. Here, let me put it in box, the even power. Now the odd powers. So the odd bars. For example, we're going to learn, we make like f of x, as we learned before, f of x equal x cubed. So we know the graph for this function. The graph look like this. Is 0 goes up, and here it goes down. And this is again my x-axis here, y-axis. Same things, we have to know how to graph f of x equal x to the 5. It is similar to x to the 3 or x cubed, but the same things like before, the difference is between 0 and 1 will be closer to the x-axis. So let me show you in the graph. So here, this is 0, this is 1. The graph from 0 to 1 will be more closer to the x-axis. At 1 is 1. So the graph will be something like this. Closer, then goes up. And here, same things. This is 1. Here, minus 1. Here's minus 1. Same things here is 1. Minus 1. And here will be more closer to the x-axis. Then goes down. Okay? Any question for this graphs? For the linear function and the power function? Anyone has a question up to here? Okay, we finished the power functions. Now the root function. So the root functions here, root functions. For example, we have to know the graph of the function f of x equals square root of x. And also we have to know the graph of f of x equal the third root of x. So the graph for this one here, as we learned before, just to remind you, be something like that. At 0, 0. At 1 is 1. Something like that. 0, 1. For this one, has a graph something. Use the black color. It's gonna be something like this. Okay. X-axis, and this is my y-axis. This is my y-axis, and this is my x-axis. Again, x-axis, y-axis. And the last graph, before the last, we have to know the graph also for the absolute value and the reciprocal functions. So for the reciprocal functions, we have to know the graph of the function f of x equal 1 over x, and the graph of the function f of x equal 1 over x squared. And the last one here, the absolute value function we have to know the graph of the function f of x equal the absolute value for x. Here, the graph of this function for 1 over x has this graph. For 1 over x, the graph will be something like this. And from this side, something like this. And for 1 over x squared, graph like this. For the graph of f of x equal the absolute value, this is, we did it like a plot point from previous section. The graph will be something like that. Okay. Yeah, this is graph of, again, this is my x-axis. Y-axis is the y, here's the x. Okay, any questions so far for these graphs? For all of them? Okay, we're going to use these graphs as the original function for our function for today. So we're going to use these functions, these graphs, as the basic graphs for graphing the other functions. Okay. Okay, let's starting for this section. So we're going to talk about the vertical, first of all, vertical and horizontal shifting. Vertical and horizontal shifting. So I'm going first of all give you the probabilities for the vertical and horizontal shifting. Then I'm going to explain the rules. So the rule says, if I have a positive numbers, this number is positive, 1, 2, 3, 4, whatever, or fraction, 1 over 2, or any like positive real numbers. Okay. So to graph the function y equal f of x plus c, this c, I have to go back to the original function, y equal f of x. Then we have to shift the original function c unit upward. What do you mean for the original function? I mean the function we drew before, this or this or this, or the rooting function or the power function. So we're going to use this function as our original functions. Then we have to shift this original function c unit upward if the question asks me to graph the function f of x plus c. If the question is graph the function y equal f of x minus c minus this number, this means we have to shift the original function c unit downward. This is vertical, up and down. Shift it up and down. C unit upward, C unit downward. Now, horizontally, to graph this function, look, the C, it's inside. Here, the C is outside the function. To graph this function, y equal f of x plus c is inside the function. We shift the original function to the right C unit. Why to the right? Because we have here positive x plus c. But if x minus c, this is meaning we have to shift the original function to the left c unit. Something wrong here. I think if a plus c, we have to shift it to the right or left. Is it true here? No, it's something wrong here. X plus not c, here minus c. So I'm going to fix it. So here minus, and here is positive. So now it's right. For positive to the left, okay? For negative to the right. So now it's right. Okay? So x minus c, we shift it to the right c unit. If x plus c, we shift it to the left c unit. Make sense? Any questions so far for the properties? Is it clear what I said? Yes, I'm going to give you example. So before I give you example here, this is vertically shifting. Vertical shifting. And for this two is horizontal shifting. Okay, let me explain before I give you example. What is the meaning of this? And what's the meaning of vertical and horizontal shifting? So suppose my graph look like this. I'm going to do 4 graphs here. I don't know if it's fit, but I'm trying my best. This is the first one because I want to graph 1, 2, 3, 4. So I need 4 graphs. So 1, 2. This goes up a little bit. Up here. So I need more 2. Third one. And fourth one. So for the first one here, suppose I want to graph the function y equal f of x plus c. And here c is positive, okay? And my graph, the original graph, for example, suppose has a graph like this. Okay? This is my original graph. This is f of x. This is f of x. The question is, graph the function y equal f of x plus c. So This means graphing the function y equal f of x plus c, this means we have to graph, by using the original graph, f of x, the blue one, I have to shift this one, c unit, upward. Why upward? Because we have plus. Going back to the rule, to graph the function y equal f of x plus c, we shift the graph, the original graph, upward c units. So we have to graph the second one. This is mean we shift the original function f of x, the blue one, c unit to the up. Suppose c unit like this. Shift it like this, c unit. So this is the graph for my function y equal f of x plus c. Here again, c unit. Make sense, the first one? Any question for the first graph here? Any question for the first graph? How to graph, like any, is it clear how to graph f of x plus c? What is the mean of moving shifting the function c unit? Okay, so now for the second one, suppose I want to graph the function y equal f of x minus c. Y equal f of x minus c. So suppose my graph, the original function, suppose something like that again. This is f of x, the original function. I need to graph this one by shifting the original one, c unit, to the down. Why down? Because we have negative c. Negative c means we shift it down c unit, and the c, look here, it's outside the function. It's not inside the function. It's not inside the parentheses of the function. So the graph will be something like that. So this is mean c unit goes down, c unit. So the red one is the graph of the function y equal f of x minus c. So the first one and the second one as the graph of the first graph and the second graph. Now for the third one, the question is graph the function y equal f of x minus c, and the c here, it's inside the parentheses of the function. So again, my original function is the blue one. Suppose has a graph like this. This is my original function f of x. The question is graph this function y equal f of x minus c. Here we have minus c, it's inside the parentheses. This is mean, what does that mean? What does that mean by using the first four rules?
Shift it to the right.
Shift it to the right, exactly. How many units?
C, whatever C
C
is.
units, exactly. So we shift it to the right, C units, because we have negative C, we shift it to the right, C unit. So the graph, the original graph, the graph will be look like this. After we shift the blue one, be something like that. So this is f of x minus c. For the last one, if I have a question, graph the function y equal f of x plus c. What does that mean? So suppose again my original graph is the blue one, something like that. how can I graph the function y equal f of x plus c? This is my f of x. How can I graph the function y equal f of x minus plus c? Christopher, he said we shifted to the left. This is true. Why? By using this property. To graph y equal f of x plus c, we shift the original function c unit to the left. So we shift this one c unit to the left like this. So the graph will be something like this. Here it goes down, up, yes. So this is f of x plus c. Okay. Any questions so far? Anyone has a question for the 40 graphs and how we shift it? Upward, downward, right, left? Okay, so now let's give you an example. So my example now, by using the graph of f of x equal, so in this case, I'm giving you the graph is f of x equal x squared. So I give you a hint. My function, my original function is f of x equal x squared. Okay. Let me change here f of x as O of x. Why? Because I need it like O is the original function. O of x equal x squared. So now graph of each of the following. Graph each of 1, g of x equal x squared plus 2. Number 1, 2. Graph s of x equal x squared minus 1. 3. D of x equal x plus 2, everything squared. Number 4, L of x equal x minus 3, everything squared. So I give you like around 2 minutes to think, or 1 minute, I mean, to think how we can graph each of these functions, okay? Okay, who will do the first one? Who will do the first one? Or give me the idea, how can I graph this function? By using the previous properties. So here, g of x equal x squared plus 2. my original function is x squared. Which property I have to use from this fourth for the first example? The first one, exactly, Christopher, thank you. So look to the first one. To graph the function y equal f of x plus c, we shift the original function, this is my original function, upwards c unit. So the question here, graph x squared plus 2. And my original function is x squared. And the number 2 is outside the function. It's not like here, like number 3. It's outside the parentheses. Okay? So to graph this function, let me give you some hints. How you think to graph this function? First of all, we write it down, g of x equal x squared plus 2. And my original function is given as O of x equal x squared. So we're going to modify my original function such that this function is gonna be close or exactly similar to the g of x. So to make this function similar to the g of x, since I have x squared, so I have to add 2 for both sides. So plus 2 plus 2 plus 2. So now I get of x plus 2 equal x squared plus 2. Now this function is exactly similar to the g of x, this function. Look, x squared plus 2, x squared plus 2. So this is mean I can say here g of x that's equal x squared plus 2 is exactly O of x, the original function, plus 2. And this is mean here we have to graph the original function, and like he said, Christopher, we have to shift the original function 2 units upward by using this property, y equal f of x plus c. This is mean we graph the original function and we shift it c unit upward. Okay, is it clear what I did here? Any question for these things? So first of all, you write down the graph, the function, you write down the original function, you try to modify the original function such that give me a function exactly similar to the g of x. So I add 2 for both sides. I get O of x plus 2 equal x squared plus 2. X squared plus 2 is the same as g of x here. Then I write down g of x equal x squared plus 2 is exactly equal the original function plus 2. Now to graph this function, I have to graph the original function O of x, this one. Then we have to shift it 2 units upward by using the property before. Okay, so let me do it. So the graph, so now to graph the g of x, we have to graph O of x, and then we shift it 2 units upward. So the original function is x squared. And by using this graphs here, f of x equal x squared, this is my default function graph, or the basic graph we have to know. All these graphs, you have to know it, okay? So the graph is parabola open upward. So this is the original function here. It's parabola open upward. So first things, we have to graph the original function of x. Okay, this is the first step. Second step, you have to shift the original function 2 units upward. So 2 units, like here 0, 0, 1, 2. And every point here goes up 2 units. Like around here, this point goes here. This point goes like around here. So the graph will be something like this. So this is O of x plus 2, and this is equal the function g of x. So the blue one is the graph for the first one, g of x. Any questions so far? No questions. Anyone except Christopher has a question?
Nope, I'm fine.
Okay. So the same things for the other function, s of x. We have to write down the original function. You modify the original function by doing adding or subtracting numbers, make it similar exactly to the s of x, then you know how to graph the function. You get the final things, you get function something like that, and we know the original function by previous slides. Then we have to do shifting right or left or wherever. Okay, let's do the second one. Who do the second one? Or tell me how it's shifted. Second one, s of x equal x squared minus 1. So again, my original function is x squared. What I have to do now? Shift down 1 unit, exactly. So shifting down the original function, Christopher, right? Cash 1, I mean. We shifted down 1 unit. Why? Because the 1 is outside the parentheses, outside the function. But let's do it step by step. So my original function is look like O of x equal x squared. Then I have to modify this function such that I make it similar exactly to this function. So what I have to do now?
Subtract 1 on both sides.
Yes, subtract 1 from both sides. So now I get O of x minus 1 equal x squared minus 1. Now this function here is exactly like this function. So I can set s of x equal x squared minus 1, this one, is equal to the original function minus 1. So this is mean the original function, I know the graph is parabola. I shifted 1 unit to the down because the minus is outside the parentheses. So the same step like before. The graph would be something like this. So the graph for the original function of x, something like that, parabola. Then I have to shift this one by using this properties here, by using this one, because O of x minus 1 is the same as s of x. I shifted 1 unit to the down. So 1 unit to the down, 0, 0 will be like here, minus 1 and 0, and all points goes to 1 unit to the down. Here is 1, 1 goes like 0, and like this. So this is s of x, it's equal the original function minus 1. The red one is the original function O of x equal x squared. Any question so far? Is it clear? Okay, now the third one. D of x equal x plus 2 square, everything square. Square, sorry. Which property I have to use from 1 to 4 here to graph the function y equal f of x plus 2?
4.
4. Look to the 4. To graph this function, I have to shift the original function to the left C unit. Because we have positive plus, we have to shift it C unit. And also the number here, it's inside the parentheses. It's not outside. Look, the 2, it is inside the parentheses. This is mean we have to use the property horizontal shifting. The property 3 and 4, horizontal shifting, to the left or to the right. But before we use the vertical shifting, to the up or to the down. Why? Because the number is outside. Now the number it's inside the parentheses. So now example 3, it's similar to the property number 4. We have to shift the original one, O of x equal x squared, to the left C unit. The C unit here, the C here is 2. We have to shift to the left 2 units. Okay? Is it clear? So the same step like here, if I want to use it, before I graph this function. So my original function again is x squared, right? Now x plus 2, it's inside the parentheses. This is mean I have to plug inside this function something to make it like similar to the d of x. What I have to plug here? What I have to plug inside the parentheses here? To make it similar to the d of x? I have to plug these things, x plus 2. So O of x, I have here about x plus 2 inside the parentheses. So now look, the O of x plus 2 give me something like x plus 2 squared. So now d of x equal x plus 2 squared is the same like the O of x plus 2. So to graph this function, I have to graph the original one and I have to shift it to the left, to the left 2 units. Why? Because we have positive 2. So the graph, something like this. So the original function is x squared so this is x squared of x equal x squared. Now I have to shift the original function by using these things to the left 2 units. So 2 units to the left here, 0, 0. Here like around -2 and 0. and everything here we have to shift it to the left. So this point here is 1 and 1, for example. This 1 and 1 should be like -1 and 1, and all points will be shifted to the left. So the graph will be like something like this. Okay, so this is O of x plus 2, and this is the same as d of x. Any questions so far? Is it clear? Anyone has a question? Okay, now the fourth, number 4. Same idea. Number 4 is L of x equal x minus 3 square. X minus 3, everything square. So again, my original function, I will use the same step, is equal x square. Here I have to plug the same things, this quantity, x minus 3, like before exactly. So I get O of x minus 3 equal x minus 3 square. Now, this function is similar to the L of x, so L of x equal O of x minus 3 is equal to x minus 3 everything square, and this is similar to this function, O of x minus 3. So which property this is used here? So I know the origin, I know how to graph the original function O of x equal x square. Now, which property I have to use for O of x minus 3? Here, so look, the minus is, first of all, the number is inside, and the number inside is negative. Which property I have to use from this fourth? Third one, thank you. So look to the third one, y equal f of x minus c. This is mean we have to shift the original function to the right c units. The original function in my example is O of x equal x square. I have to shift it 3 units to the right because c is 3. So go back again here. So function is O of x parabola O of x equal x square. Then I have to shift this one by using the third property 3 units to the right. So here 0, 0, it will be like 3 and 1, 3 and 0. And all these points, here is 1 and 1, for example. Suppose it's 1, 1, 1 here. So be like 4 and 1. Use different colors. So parabola be something like this. This is O of x minus 3, and this is the graph of L of x. L of x. Any questions so far? Any question for this example so far? Okay. If there is no questions, let's go now to the reflection. So next step in this section is reflecting curve. Reflecting graphs. So let me give you the property again for the reflecting graphs. So here, okay. So to graph the function y equal minus, the minus is outside, look. Minus, here is minus f of x. We reflect the original graph y equal f of x around the x-axis. So if the question asks me graph the function minus f of x, I have to graph the original function, then I have to reflect it around the x-axis. Why around the x-axis? Because the minus outside the function. But to graph this function y equal f of minus x, the minus is inside the parentheses, I have to graph the original function y equal f of x, then I have to reflect it around the y-axis. So if the minus is outside the function around the x-axis, if the minus is inside the parentheses inside the function, I reflect it around the y-axis. Let me explain more by graphing. Okay. So here I want to graph y equal minus f of x, and here I want to graph y equal f of minus x. So suppose my graph for this one here is something like this. This is my f of x. The question is, ask me, graph this function, graph the minus f of x. Let me move it a little bit. This is my function, and the is f of x, and the question is graph minus f of x. So look to the properties here. Number one, to graph the function y equal minus f of x, the minus outside, look, the minus outside here. So this is mean I have to graph the original function. The original function is given. I have to reflect it around the x-axis. So this is my x-axis. This is my mirror. Okay. So this is my mirror here. I'll put here a mirror. Then I have to graph, reflect every point in this curve around this line, around the x-axis. So this is my x-axis here. Here is my y-axis. Now I want to graph this curve around this mirror. So this is mean the distance from this point to this point must be the same. So the distance from here, this point and this point will be like around here. So the point here, the new point, will be around here. So this point will be here. This point will reflect it to this point. This point reflected around this point. This point, after we reflect around the x-axis, be like around here. This point will like around here. So the new graph will be something like this, like that, going up like this. Now it's look nice. So like around something like this, goes down and goes up again. So this is the reflecting curve around the x-axis. So this is mean the distance here from this point and this point here, to be black color, distance is the same. So here the distance is like the same like this distance. And the same things for this point here. The point is here. And this point have the same distance. Is it clear? For the first property, y equal minus f of x. This is equal here, y equal minus f of x. Now for the second one, suppose my graph has a shape like something like this. Like this. No, it's not nice. Something like this. The question is graph y equal f of minus x. So this is my f of x. How can I graph the function y equal f of minus x? So look again, the minus, it's inside the parentheses. This is mean we have to use the second property. Look, second property, to graph the function this, we have to reflect the original function around the y-axis. So my mirror now is the y-axis, this axis. So this is my mirror here. And I have to reflect every point in this curve around this axis. So this point, like around here. This point will be like around here. This point will be like around here. This point like around something like here. So the new curve will be something close to this curve, the pink one. So this is one is y equal f of minus x. Any questions so far for the first and the second graphs? So here I can set reflecting around x-axis, here reflecting around y-axis. Any questions so far for the first and second reflecting? Anyone has a question? Okay, I think no questions. So let's give example. So the example now, graph the graph the function. First one, f of x equal minus x squared. Second one, g of x equal square root of minus x. Who will give me idea how can I graph this one? Or I can give you, okay, let me give you 1 minute to think how to graph the first and the second one. Or give me any idea how to graph the first and the second one.
Is it
Yes.
is the first one like a upside down parabola?
Is a parabola upside down, like the open parabola is where?
So I guess it's in the negative area. I forgot.
Yes, this is true. Thank you so much. This is right.
Really?
Yes. For the second one, who would do the second one? For the second one, any idea for the second one? Yes, Stephen.
Well, I know what's going to the negative side.
Negative side, but reflecting around which axis here?
The y-axis.
Yeah.
The y-axis. Why? Who said the y-axis?
I did.
Why? That's true. Why?
Wait.
Because the negative is
Is
The negative in the y-axis.
inside the function. Okay, inside the function. Let me explain more. For the first one, what is my original function here? I mean, for the original function, the graphs for the first slides here. This is the original function. I'm gonna take this one, call it as my original function. F of x equal x squared, f of x equal x to the 4. All of this my original functions. What is my original function here? What is my original function? What is it?
X squared.
Yes, is x squared. This is my original function. Now I have to modify in this function such that I make a function similar to the f of x. So what I have to do now here? Open. What I have to do? Like what I have to do to make this function similar to the f of x?
Multiply by -1.
Yes, multiply by -1 for both sides. So now I get O minus O of x equal minus x squared. Now, this means, look, this function is exactly similar to this function. So this means f of x is equal minus x squared equal minus outside the function of x. And this here minus O of x, this is mean we have to graph the original function. O of x is a parabola, open upward. Then we have to reflect it around the x-axis. Why? Because the negative outside. And the reflection of this function is the same as exactly the function f of x equal minus x squared. So the first step, I have to graph the function O of x. the graph of O of x by using the first and second slide from the before is a parabola open upward, something like this. This is O of x. Now to graph minus O of x by using the reflection rules, the minus is outside here. Look, outside the function. This is mean we have to graph the function, then we have to reflect it around the x-axis. So I graph the original function, then I have to reflect it around the x-axis. My mirror is my x-axis. So this is my mirror here. So everything reflecting around this one. The 0, 0 stay the 0, 0. 1 and 1 be minus 1 and 1. So the graph will be something like this. So this is minus O of x, and this is the graph of my function f of x. Is it clear how you think to graph the function? So my graph, my original graph is the blue one, minus O of x, f of x. For the second one, the same idea. What's my original function here? What is my original function? Which function I have to choose from the first and second slide, similar to this function? Look to this function. Is it similar to the other function, to my example function?
Yes.
Yes.
So this is my original function. F of x equal O of x equals x squared. So O of x equal x squared. Now what I have to do to make the original function similar to the g of x, I have to plug here inside negative x. Okay, so after I plug negative x, I get O of minus x equal square root of minus x, and this is equal g of x, this function. So now to graph the original function g of x equals square root of minus x, and this is equal again O of minus x. So the minus g of x, as we learn from the reflection, or we look into the reflection here, the minus is inside by using the second property. This is meaning we have to graph the original one reflected around the y-axis. My original function is the square root of x. So this is my original function. And I know how to graph the original function by using the previous slides, the first and second slide. So this is O of x equals square root of x. Now to graph this function g of x, I have to reflect the original function around which axis? The y-axis. Why? Because the minus is inside the function, the original function. So this is my y-axis here. And everything I have to reflect around this one. So 0, 0 would be stay 0, 0. This point like around here. This one is like around here. So the graph will be something like this. This is O of minus x and is equal g of x. Any questions so far? Any question for these things? Okay, Now let's go to the last things of reflection, shrinking and stretching. Okay. So, but I'm going to use talking about the vertical. First one is the vertical stretching. The vertical stretching and shrinking. So again, let me give you the properties. Okay, same like before. To graph the function y equals c times f of x, if I have a number, now I have number multiplied by the function from outside. If it's outside, this is mean vertical shift, stretching and shifting and shrinking. So, but this number has some property. If this number is greater than 1, like for example, 2, 3, 4, 5, up to infinity, this means we have to graph the original function, then we have to do stretching of the original function vertically. Okay? If this number here, c, is between 0 and 1, for example, 1 over 2, 1/2, or 1 over 4, or 1 over 3, all this number between 0 and 1, this means to graph this function, I have to graph the original one, then I have to shrink the original one vertically. Okay? Let me explain that by graphing. So suppose my graph is my function is the red one. It's look like this, something like this. This is f of x. The question is graph the function y equal c f of x, and here is c is greater than 1, like 2, 3, 4, 5, any number greater than 1. So any number greater than 1, I have to graph the original one, then I have to do stretching of the vertically to the original function. Stretching vertically means this is vertically, first of all, means I have to stretch this function vertically like this, something like this. This is mean stretching vertically, like this. Up, because the zeros keep zeros. And here also vertically will be something like this. This is the graph y equal c f of x. The red one is the original function, y equal f of x. Is it clear what I said? How to do the vertically stretching? Any question for the stretching for the first one? Okay, now for y equal c f of x, and c is between 0 and 1. C here is a number between 0 and 1. And my graph is the red one, something like this. This is y equal f of x. The question is, graph the function y equals c times f of x and c between 0 and 1. So to graph this one by using the property here, I have to graph the original function, then I have to do shrinking for the original function vertically. Why vertically? Because the c outside the function. So this is vertically means, and we do shrinking. So shrinking will be like something like this. Here's the 0 keeps zeros, and shrinking will be like something inside. This is y equal, the red one, the blue one is y equal c f of x, and c is between 0 and 1. Here c is greater than 1. Any question so far? Is it clear? This is x-axis, y-axis, y-axis, x-axis. Anyone has a question? Anyone has a question? Okay. Now we have like around 5 minutes before the quiz start. Let me do also the horizontal stretching and shrinking. I gave you the idea. Next time I'm going to give you the example for the vertical and the horizontal stretching and shrinking. So now for the horizontal, again, stretching and shrinking. Again, I'm going to give you again the property. The property says this. So now to graph the function f of c of x, look, the c is inside the function, but here the c is outside the function, outside the vertical, inside horizontal we do. If this c is between 0 and 1, we do stretching for the graph. Here vice versa for the vertical. If c here between 0 and 1, we do shrinking, but here we do stretching for the function. And also if c is greater than 1, vice versa for the vertical, we do shrinking, but there we do stretching. So opposite to each other, okay? So here we do stretching if c between 0 and 1. By graphing the original function, we do stretching horizontally. Same things, if c is greater than 1, we graph the original function, we do horizontally shrinking. Why? Because the c, it's inside the function. So we have, first of all, check where is c. Is it outside or it's inside the function? Then you go back to do the property if c is between 0 and 1 or if c is greater than 1. Now the same things, let me graph a graph to explain how we do the shrinking and stretching. So again, suppose my graph, the blue one, the red one, same things here. Here I want to graph y equal c f of c of x, c here between 0 and 1, here y equal f of c of x, and c is greater than 1. So for this one, c between 0 and 1, we do, because the c it's inside the function, this means we have to do horizontally. Horizontally means something like this. And here again, the same things, horizontal, same thing like this. So c is between 0 and 1. This is mean we have to do stretching by using the first property, stretching for the original function. Stretching mean will be like close to the y-axis. Like mean in the graph would be something like this. This is mean stretching. We stretch the red curve closing to the y-axis. And the same things from this side. So this is the graph of y equal f of c of x. For this one, because c is greater than 1, this is mean we have to do shrinking for the graph horizontally. Shrinking mean this is the original one, or like it would be like more far from the y-axis. This is mean the graph would be something like this. Okay, so this is y equal f of c of x, and here c is greater than 1. Any questions so far? This is again my x-axis, and this is my y-axis. The y-axis, and here is the x-axis. Okay, any question? Anyone has a question? Is it clear, the horizontal and vertical stretching and shrinking? Okay, so we're going to stop up to here today. Next time I'm going to give you examples for this horizontal and vertical stretching and shrinking, and we're going to continue this section. Thank you.